Today what we're going to cover is 19.2 quadrilateral theorems. So there are some special quadrilaterals. Quadrilateral means it has actually four sides, okay? So there are some quadrilaterals that you actually need to know. For example, rhombus. So what is a rhombus? Basically, you need to know that a rhombus has four equal sides, okay? And that the opposite sides are parallel to each other, okay? So therefore, if we can show that also another property of a rhombus is such that they will intersect, the diagonals will intersect and you form 90 degrees. So if you can actually be able to prove that the diagonals form a 90-degree angle, you also get the condition for a rhombus itself. So, okay, sometimes, okay, maybe we're able to show that ABCD has two pairs of equal and opposite angles. So basically what this page is trying to tell you is this. So for example, if I have something that looks like this, okay, so if I'm somehow able to prove that this angle and this angle, they are equal, all right, think about it. In a rhombus, it is true that the opposite angles are equal, but does that prove there's a rhombus? It does not. In fact, right, in this case, if you're able to prove that, or you have proven that it is a parallelogram itself. So what you actually need to do is to actually go through in your textbook itself these few pages whereby they actually give you all the different properties of the quadrilaterals. Can be found on page 172. For example, okay, what are the conditions? So you actually need to know, okay, the conditions for which it's a square. For example, a square is if you can prove that you got four equal sides and four right angles is a square, or if you can prove that the diagonals are equal and bisect each other at right angles. So for a rhombus, they bisect each other at a right angle. But for a square, which is a spectral kind of rhombus, if you think about it, the both diagonals are equal and they intersect at 90 degrees. So you take some time to go read all these conditions, not only for the square, but for the rectangle as well. Okay, what are certain properties that they need to actually prove? Same for the rhombus, as we spoke about earlier. The parallelogram, for example, if you prove that there's two pairs of parallel sides or two pairs of equal opposite sides, you can prove it's parallelogram. For a kite, okay, what we have is two pairs of adjacent sides are equal. So like this and this are equal, or this and this are equal, or the diagonal bisects a pair of opposite angles. So if you have a diagonal like this angle is equal. If a diagonal like this, these two angles are equal. And for a trapezium, that's the simplest one. If you are able to prove that a pair of opposite sides are parallel, then you have very easily proven that a shape is a trapezium itself. Now, I'll just use the properties. I will leave it to you to read the properties on page 172. You have to read and you have to know them, okay? You don't need to memorize them word by word, but logically speaking, you should be able to have a good grasp on what are the equivalent conditions that are required to prove that certain quadrilateral is maybe a rhombus or parallelogram or a kite. So that one, please go through it in your textbook, page 172. Now, I will just directly delve into some examples on how to actually use these properties. So now, in example 5, found on page 173 of the textbook itself, it shows a quadrilateral ABCD. I know, okay, it looks, okay, like a parallelogram, okay, but now they never say anything, so you cannot assume. So, but what they do tell us is that AD and BC are equal, and CD and AB are equal. So what we're going to do is we're going to start with, first, they want us to prove that the triangle ADC and CBA are congruent. So if you remember from our previous 19.1, there are certain ways to prove congruency. Okay, for example, there's SAS, there's SSS, okay? So RHS for congruency as well. You need to have these at your fingertips before you prove that. So now let's just try, okay, triangle ADC and triangle CBA. First and foremost, all right, what we can say is, I will write down that AD is equals to CB. Okay, why that is so? This is given. Where is it given? It is given right here. Similarly, we also know that CD is equals to AB. Same thing, it is something that is given to us. Last but not least, okay, what we need to say is that we need another side, okay. We can see that they share the side AC. So AC is common. Hence, in this case, triangle ADC and triangle CBA are congruent. Okay, and what is the condition there that we have used? We have used the SSS proof itself. Part 2, AC and BD bisect each other. Okay, so AC and BD bisect. So it means that if they bisect, this and this are equal, and BE and ED are equal itself. So the necessary condition here is such that, okay, not necessary condition, but how we will actually prove it is to say that since, okay, I know that AD is equals to CD, okay, and CD is equals to AB. So when the two opposite sides are equal, okay, what we know here is AD and CD are equal. AD and CB are equal. My mistake there. Okay, AB and CB are equal. Okay, AD, CB are equal. CD and AB are equal. When two pairs of opposite sides are equal, okay, what we can actually say that we can conclude that ABCD is actually a parallelogram. So, if ABCD is a parallelogram, what is a special thing about parallelogram is that, right, the two diagonals will bisect each other. All of this information can be found on page 172 for parallelogram itself. So I can conclude that because it's a parallelogram, hence AC and BD necessarily will bisect each other. Okay, why don't you pause the video now and try 5 itself. Once you're ready, please unpause the video and I will run you through how to actually do try 5. Okay, so now in try 5, first and foremost, what we know that we're trying to prove that ADB and CBD are congruent. So it shows a quadrilateral, the two sides, and AD equals to BC. So quite simple, if I just write down AD is equals to BC, that is a given. Also, since they are parallel here, I know that angle ADB and angle CBD are equal because of alternate angles and parallel sides. Also, okay, what we also know is that DB and equals to BD is a common side. Instead of writing this statement here, another way we can write it is BD is a common side. I will actually prefer to write that. So since, okay, we have two sides and the included angle, two corresponding sides are equal and the included angle is equal, so therefore by SAS proof, okay, we prove that ADB and CBD are actually congruent itself. Okay, now since in ABCD, I know that AD is parallel to BC, so these two are parallel, and AD is equals to BC is given. So in this case, what we have is for two sides to be equal in length and they are parallel, if you join it up, what you necessarily form is a parallelogram. So we can actually conclude that ABCD is a parallelogram. So if it's a parallelogram, it therefore means that AB and DC, the opposite sides of parallelogram, are equal, and that AB is parallel to DC itself. And that is it for part 1 of 19.2.